After radioactivity, write down definition of radioactivity. The spontaneous emission of radiation. The spontaneous emission of radiation. The spontaneous emission of radiation from radioactivity. It's called radioactivity. It's called radioactivity. Emits the substance which emits such radiation. The substance which emits such radiation called a radioactive substance. Right. Radioactivity is caused due to instability of nucleus. Due to unstable nucleus, an unstable nucleus disintegrates, giving out radiations. Full stop. In unstable nucleus, the number of neutrons or protons are found excessive, found excessive, and the nucleus having NP ratio, right, that is N is to P or P is to N ratio, N is to P or P is to N, are found to be unstable, and radioactive in nature. Next point you write. Radioactivity is a nuclear phenomenon. Radioactivity is a nuclear phenomenon because it takes place due to disintegration of nucleus. And it cannot be controlled. By chemical or physical activity. such as by chemical reaction, such as by chemical reaction or by melting, comma freezing, etc. By melting, comma freezing. The element, that the atom, just like the atom whose atomic number exceeds 82, under bracket you write lead 8220, Pb 82204 are found to be radioactive in nature. All atoms more than 82 are radioactive. Okay, ready? So now let's explain. You can just catch up. You can just copy the notes. The last chapter we are doing, that is radioactivity. Okay. What is radioactivity? It is a phenomenon radiation from a substance is called radioactivity. What is the meaning? It's the energy released from a substance spontaneously, that is called radioactivity. What is the cause of radioactivity? Radioactivity is caused due to disintegration of nucleus or variability of nucleus. Nucleus of an atom becomes unstable, and unstable nucleus disintegrates to emit radiations. You know the meaning of disintegrate? Disintegrate, it becomes smaller inside, it breaks up. It will decrease in size slowly like this, and in that process it emits radiation. Now the question is, what makes a nucleus unstable or radioactive? We say excessive number of neutrons or protons in that nucleus will make the nucleus unstable. If a nucleus contains excessive number of neutrons are in excess or protons are in excess, they are found to be unstable and disintegrating to give out radiations. So in what excess quantity they should be? So the answer says the ratio of neutron is to proton or proton is to neutron exceeding 1.5. Ratio of neutron to proton NP ratio or PM ratio should exceed 1.5. All those atoms in the periodic table above lead, above that 82, they all are found to be. I can just give one example. Suppose uranium and uranium is 92 and oxygen is 235. How many? This is called what? Do you know what is this called? This is called atomic number, no? This is called atomic number denoted by Z. This is known as atomic number. You should know that. Atomic number, this is known as mass number. So we will bother about the nucleus. What is actually atomic number? It is protons or the number of neutrons. What a nucleus. Atomic number of a nucleus I am saying, because it is all due to the instability of nucleus. No. What is the atomic number here? The number of protons. Okay. So this represents the number of neutrons, the number of protons. How many protons are there in this nucleus? How many protons are there? 92. This minus this, no? I'll subtract and number of neutrons will come 143 will come. And when you divide the number of neutrons in excess, no? How much this one, let us check now. N by P, you will divide 143 2. When you divide, your answer will come more than 1.5. It comes 1.5, that more than 1.5. Such a nucleus is unstable. What are the examples of radioactive materials? There are many examples. Common examples you know: uranium, which emits radiation, thorium, polonium, strontium, selenium, all those with IUM, no, so they all series in chemistry. This is there. Above 82, all are radioactive in nature. They are contributing radiation and spontaneously. Radiation means energy, and they are radioactive in nature. Sometimes they may give like this. Suppose X and Y, there are two nucleus, and this is having 50. Next one is having 20, and this is having 80, like that. And they're asking, check which of them is a radioactive nucleus, or which of the nucleus is unstable, they will say, or which of radioactive. So how to know? First, proton is how much here? 20. Neutron is how much? Subtract 50 by P. The answer is 30 by 20. The answer is coming exactly 1.5. Still 1.5 is stable, and anything more than 1.5 is unstable. The proton, how many protons are there? 20. How many need to track? You get the number of neutrons coming 60. N by P value is coming 60 by 23, no? You say this one is radioactive nucleus and this one is not. Sometimes it may happen that the protons are in excess. It may happen. Suppose I give one example. Suppose there is an element Z having atomic number 20 and the mass number is suppose 25. How many protons are there in it? How many protons? This is this one. You say protons are 20. This one atomic number, mass number. How many neutrons are there? We subtract 25 minus 20 is coming. This time we find protons are in excess. It can go the other way also. One of them has to be in excess. By how much? More than 1.5. So this time we see proton is in excess. Then the neutrons will divide 20 by 5. What is the answer here? 4. This is also radioactive. It can be the other way also. Like sometimes in the natural radioactive elements, no, that we find the neutrons are in excess. But we have another category which is called artificial one. In artificial one, we can't add neutrons to the nucleus, but we can add protons. We make number of protons in excess. And they are called artificial radioactive substance. But they're also radioactive only. One is natural, one is artificial. Which one is better? We say artificial one. Why? Because artificial radioactive elements, the radioactive radiations will not be that powerful, will not be harmful. Whereas the natural radioactive materials, radiations are very strong and very harmful. So we are going for artificial one. You know, the injections and all are being used on the radioactive materials injection, like nuclear medicine, they say. Chemotherapy, you must have heard of cancer treatment. So cobalt 60 and also, they are all making radioactive artificially. That is better actually, safer. Otherwise, the natural one is quite powerful and it will be harmful. So you understand the logic there? What causes radioactivity to take place? What is the answer? You said the instability of nucleus. What happens to an unstable nucleus? It disintegrates to emit radiations. What makes a nucleus unstable? Excessive number of neutrons or the protons. How much in excess? I gave the NP ratio exceeding 1.5. In the periodic table, Which atoms are found to be radioactive? Those whose atomic number exceeds 82, that is lead one, after lead, whatever comes. Still lead is a stable nucleus, naturally. And after lead, we are having all radioactive. An example I give. And another point, cannot be controlled by chemical reaction or by physical activity such as heating, melting, freezing, solidifying, whatever you do, its radioactive nature will not change. Radioactivity will still be taking place. You cannot prevent. Why? Because it is a nuclear phenomenon. It takes place due to nucleus, no? And the nucleus never takes part in chemical reaction. It is electron, no, which will be either transferred or shared, no, between the two in order to form a compound and all. So in the chemical reaction, nucleus never takes part. That's why it cannot be controlled. I say uranium is taking part in chemical reaction and is forming a salt, uranium salt, suppose, uranium chloride, or uranium oxide is oxidized. Will the radioactive nature of uranium change? The answer is no. That's why very dangerous with this one. If you are taking the injection of this one, no, that very powerful radioactive material, no medicine will work on it because it will not listen to any medicine. You can't reduce the radiation, the power. Suppose some powerful radiation has entered your body and you think and it is giving a harmful effect. So, do you have any other medicine to reduce the strength? No, we cannot reduce it. It will go with the time. It will be a time because if the radiation is small, so slowly it will be, because the nucleus is becoming disintegrated, is becoming smaller in size. A time comes when it becomes stable. So it will not. I mean, power will be lost itself only by nature. But you can't have any medicine allowed to work. That uranium salt is melted. Its radioactive nature will change. Answer is no, it will not change because it is a nuclear phenomenon. This question has come many times in ICC. You say thorium is oxidized. What happens to radioactive nature? You say it will not change. Why? Because it is a nuclear phenomenon. And the nucleus never does not take part in any chemical reaction. Or uranium salt is melted. Will its radioactive nature change? The answer is no, there also. Because it's a nuclear phenomenon. Understood? Got the idea? What makes the nucleus unstable? I said the excessive number of neutrons or the protons. Radiation is the energy released by that substance. But I'll tell you the natural radioactive materials, natural radioactive material takes very long time to lose its radiation and to become stable. They take very long time. We are determining the age of Earth something billion years. So on the basis of radioactive materials, there is one isotope of carbon, that is C14, which is radioisotope, which is radioactive in nature. And so radiation hasn't stopped. So the radiation enters the body, or the rocks or trees or whatever fossils. That radiation system will be there. So on counting the rate of radiation, we determine the age and all. This is the technique that is called radiocarbon dating technique. Understood? Huh? So it takes very long time for the radiations to go away completely from the radioactive material. I'm talking about particularly the natural one. And even people go for chemotherapy. So you see, quite 1 year or at least 2 years, they will have the effect in their body. Their hairs and loss. Do you know all that? No. After chemotherapy, the hairs will go away. And they will feel very fragile, weak and all that, the person who has undergone this therapy. It happens. So the side effects or whatever you say, the harmful effect, it stays for a long time. But of course, it is not that powerful as the natural one. So ultimately, it will go away. Understood? Okay. Now, next thing you need to learn is Who discovered radioactivity? Yeah, just understand. The name of the scientist was Henry Becquerel. He discovered the phenomenon of radioactivity and how accidentally he discovered. What happened? He was a chemist actually. Let me tell you, he was a chemist. He was doing some experiment in chemistry lab with the uranium salt. He had a uranium platinocyanide salt. But just keep in mind the story you don't have to tell her. Just understand, huh? All the radioactivities were discovered and certain questions on that. So he was performing some experiment in the chemistry lab with the uranium salt, and suddenly he was getting extra quantity of heat. Though he did not supply any heat, but he was getting heat generated there. So he started thinking, something wrong with this salt or what? Why the heat is automatically getting generated, though without any supply of heat? Then he thought that there is something wrong with this. Let us check any kind of invisible radiation, because all the radiations we cannot see, only light radiations we can see. Like X-rays, other radiations, they are all powerful energetic rays. We don't see them. But we have the evidences we make use of also. So he started thinking something wrong with the salt or what. Then he tested the salt. Okay, what he did, he took the salt in a dark room and he kept the salt in a lead container. Lead. Lead is a very dense metal, so it will be preventing the radiation to come out from it. Lead is known to be a good absorber of radiations, the dense metal. He took lead container, and in the lead container he kept that uranium salt, which he was using in the chemistry lab. And on top of it, he placed a photographic plate. On top of it, photographic plate was placed on top of the container. And of course, in the dark room, because the photographic, if you have light there in the room, no, then the photographic plate will get affected due to that light. So you will not know whether this is affected due to this light or this is the radiation from this. So that's why in the dark room. So he placed the photographic plate on top of the container, and after some time he removed the photographic and he saw it was affected all over. There were shadows everywhere. And that is the indication, any kind of radiation, invisible also, will be affecting the photographic plate, any kind. And the photographic plate was badly affected. Then he was sure, oh, something is coming out from this, some radiation. And to check the nature of the radiation, phone by 9 to 10. Okay. Then to check the nature of the radiation, what we did, he placed the photographic plate now above it, above the container here like this, and at the same time he applied an electric field to check the nature of the radiation. So the electric field means one side he applied positive, one side he applied negative plate. How can he apply? The two plates he took and he connected this way, like this, like with this side is positive, this plate will become positive, this is negative side, this plate is negative, like that. And this time he saw only 3 distinct spots. One spot was, only 3 spots he observed now. One spot was exactly at the center of the plate, one was this side, and one was this side, like this. There were 3 spots only seen. Then on the basis of these 3 spots, he came to conclusion that there are 3 types of radiations coming out from the radioactive material. And he named them alpha, beta, and gamma. He named them alpha, beta, and gamma. The one coming towards the negative side, no, it is coming towards the negative side, that must be having positive charges. That's if positive, negative attracts the positive, no. This must be positively charged in nature, that was named as alpha. And the one moving towards the positive side, that must be containing negative charge. So he named this as beta. And the one which is going neither towards the negative side nor towards the positive side, that means it is uncharged, and that was gamma. This was center one. This was gamma. Moving towards the negative side must be positive charge, na? So it is alpha. And the one which is going towards the positive side, must be containing negative charge itself, and that is called beta, negatively charged for radiations. And the one uncharged radiations was gamma, which is coming at the center. Understand? And on further investigations, and he named these rays alpha, beta, and gamma. Okay. These rays are also known as Becquerel rays. Becquerel. So the scientist who discovered the phenomenon of radioactivity was Becquerel, Henry Becquerel, and he named these rays as Becquerel rays. Okay. On further investigation, it is found that beta is nothing but it is an electron. Electron we write like this. This is the symbol of electron. Electron we write like this. Electron ko charge is minus and mass is almost zero. So we write that on top. -10. This is the symbol for electron used. Okay. Beta was nothing but a kind of electron. And alpha was positively charged. It was this one, helium double ions, positive ions. We call it doubly ionized helium atom, doubly ionized, double ion, two positive ions. It is read as doubly ionized helium atom. Understand? And gamma was found to be electromagnetic in nature. Electromagnetic means, similar to light, no mass and no charge. It is same as light. Its property is same as the property of light. Light can travel through vacuum, gamma also can travel through vacuum. Light does not have a mass, neither it has a charge. Same thing happens. Light is unaffected by electric field, magnetic field. Gamma also is unaffected by electric field, magnetic field. So property is very much similar to the light. That's why in the semester one you studied the electromagnetic waves or electromagnetic spectrum. There were 7 of them. The first was gamma. Then comes X-rays, then UV rays, then visible light, then infrared, then microwave, then radio waves, like that. Understand, no? Whereas alpha, they are containing masses and they have got charge also. That's why they are not electromagnetic in nature. They are like other particles. They are deviated, they are deflected by electric field. And even if you bring a magnetic field, then also they will respond. They will get deflected. But gamma will not. Okay. Helium, this is helium atom, no? Or rather you can say its mass is equal to the mass of the helium nucleus. And this one is same as electron, mass of the electron. Which one is heavier? Alpha and beta, out of the two, which one will be heavier? Alpha will be much, much heavier. Because alpha is helium nucleus, it contains 2 protons and 2 neutrons. Electron mass is very small. Proton mass is 2000 times more than the electron mass. Nearly 1836 and 1836 times actually. A proton is 1836 times heavier than an electron. And neutron is even slightly heavier than proton. So definitely nucleus will be much more heavier than the electron, much more heavier. So that is the reason it was a negative sign, but with lesser angle. The angle of deflection is least for alpha. At all. That 0 degree for this. But out of alpha, both of them are deflecting, no? So which one deviates with the greatest angle? The greatest, because it is much lighter than alpha. And the alpha is deviating with a lesser angle. That is from here, no, if you want to show, you can show this way, like this. Which has got greater angle loss here? Beta. Beta will be at the device because it is much lighter than alpha. If the weight is less, it will be bending more, no, from the other side. If the weight is less, due to heavy weight, it will be bending but with a lesser angle. Okay. Sometimes they may not draw this diagram, they may just show like this. On a photographic plate, when exposed to uranium salt, three spots are seen. So there is one spot they are showing here, one spot they are showing here, and one is shown here. Identify them. Alpha is alpha, beta, and gamma. Tell me which is the. Suppose this is number one. They are given the number here. Number 1, 2, 3. Tell me number one is what? How do you know? Because it is closest to the center, which is deflecting with a lesser angle. It must be heavier, no? Number 2 is what? Visco, gamma, deflecting towards the other side. This one is at a larger distance from the center, no? That is deflecting with a greater angle. This is beta. Okay? Understood? Okay. Now, who did this experiment? Henry Becquerel. Now, why did you come then? Go. You watch the recording then. Now you can just write down the comparison between alpha, beta, and gamma. Those three one. Write down here alpha, beta, and gamma. Make a column. I mean table. Having alpha, beta, and gamma. What are they? These are the three types of radiations from a radioactive material. Radioactive substance. Alpha, beta, and gamma. Right, point number 1. That it is doubly ionized. It is doubly ionized helium atom. Helium atom. Right, like this. He++. It is doubly ionized helium atom. He on top 2+. It can charge only one. He++. Here you write. It is a here beta. It is a fast-moving electron. It is a fast-moving electron emitted from nucleus. Emitted from nucleus. Yes. Then gamma you write. It is an electromagnetic wave. It is an electromagnetic wave. Two of them are particles and one of them is wave. Which one is wave? Gamma. Now point number 2 you write. Its mass is equal to 2,4. This mass is helium 2,4. Under bracket you write mass of helium nucleus. Mass of helium nucleus. Mass of helium nucleus. Its mass is equal to He24, right under bracket, mass of helium nucleus, close bracket. Helium nucleus. Bracket is the mass of helium nucleus. Okay. Now go to this one, beta. That its mass is equal to mass of an electron. Mass is equal to mass of an electron. Under bracket you write -1, 0. Mass of an electron. Then other side you write its mass is its mass is zero. Its mass is zero. No mass. It's a wave. So mass is only. Number 3. Contains two positive charges. It contains two positive charges. It contains two positive charges. And here you write, it contains a single negative charge. It contains a single negative charge. Single negative charge. And the last one you write, its charge is zero. Its charge is zero. One number next. Right. Its speed in air is 10 to the power of 7 meter per second. 10 to the power of 7 meter per second. Other side, its speed is equal to beta side. Its speed is equal to 90% of the speed of light. 90%. 90% of speed of light. 90% of speed of light. Light. 10 to the power of 7. Oh, 10 to the power of 7 meter per second. Then write last one. Its speed is equal to speed of light. That is how much? 3 into 10 to the power of 8. Its speed is equal to the speed of light. Under bracket you can add 3 into 10 to the power of 8 meter per second. Now next one you write. Its stopping distance in air is 1 meter. 1 meter. And the other side, right? Its stopping distance in air is 100 meters. And there, right? Its stopping distance in air is 10,000 meters. Okay. Next one you write. It can be stopped by thin paper, alpha side. It can be stopped by thin paper, comma, human skin, etc. Beta side, right? It can be stopped by 2 millimeter thick, 2 mm thick lead or 5 mm thick lead, 5 mm thick aluminum, 5 mm thick aluminum. And other side you write, it can be stopped by 5 mm thick lead, 5 millimeter thick lead or a few meter thick iron few meter thick iron. Right, the last next one you write. It has low penetrating power. It has low penetrating power, that is alpha. Next one you write. It has higher penetrating power. And the last one you write. The most penetrating power. Most harmful penetrating power. And then write last one. Highest ionizing power. Alpha said highest ionizing power. And beta said less ionizing power. And the last one, right? Least ionizing power. Least ionizing power. So these are one of the differences. Huh? Just just answer one question and then go. Okay, today. Huh? Can a hydrogen atom emit an alpha particle? Can a hydrogen nucleus or hydrogen atom emit an alpha particle? Less than the mass of helium. Yes or no? Nucleus can emit more mass. Is it possible? If you have a can it emit a particle of larger mass? Not possible. That's why hydrogen nucleus can never emit alpha. B because electron they have. Electron is alpha. Hydrogen